Alright, this is the third and final part of our review of arc length, sector area, and volume. In this video, we will do problems where you're not given the picture, and often you're going to have to find one quantity and then use that to find another quantity. So a lot of these are like two problems in one with no picture. Double jeopardy. It's almost unfair. Okay, the surface area of a sphere is blah blah blah. Find its volume. Okay, the key to these problems is when you're given a quantity, go ahead and set up the formula for that quantity and see what you can find. Usually it's the radius that you can find, and once you have the radius, you can find whatever you want with it. So they gave us the surface area of a sphere. So what's the formula for the surface area of a sphere? The surface area of a sphere is given by 4 pi r squared. So start by writing down that formula. Okay, so if the surface area of a sphere is 3.24 pi, that means this should equal 3, did I say 3.24? I meant 324 pi. Then this surface area should equal 324 pi. Okay, so I'll just erase that s, and let's go ahead and solve this equation. So I'm going to be solving for r, so let me go ahead and divide everything by 4 pi to get closer to having r by itself. Alright, if I divide by 4 pi, then notice that not only do these 4 pi's cancel out, of course, but over here these pi's cancel out. So you need not type them into your calculator at all. Alright, they're gone. So what we will have is we will have r squared equals, alright, whatever 324 divided by 4 is. So let's see, 324 divided by 4. That's 81. Okay, so r squared is 81. So of course, if I want to find the radius, I am going to take the square root of both sides. Alright, so that tells me that the radius is 9. Alright, and we had inches squared, so the radius is 9 inches. Alright, so that's good to know. It's not the final answer, alright, but it's part of the way there. Alright, now we are supposed to find the volume. So so let's start over and talk about volume. So the volume of a sphere is 1/3, I'm sorry, not 1/3, 4/3 pi r cubed. Okay, so the volume is going to be 4/3 pi, and the radius is 9. Okay, so 4/3 pi times 9 cubed. Alrighty then. So 4/3 pi times 9 to the 3rd power. That's 972 pi. Alright, cubic inches, alright, because it's volume. But we're supposed to put everything as a decimal. So that's 3053.63. I don't think I'll remember all that, so 3053.63. So that is the volume, and that's the answer to number 11. Alright, number 12. If a cone-shaped candle is 4 inches tall and has a circumference of 10 inches, what is the volume of wax needed to make the candle? Okay, so we're told that the cone is 4 inches tall. All right, so this is 4 inches, and we're told that it has a circumference of 10 inches. Okay, so we have 10 inches for the circumference, all right, which is, of course, is the entire way around. So we need to find the volume. But as we begin to try to find the volume, we know that the formula for volume of a cone is 1/3 the area of the base times the height. So we need 1/3 times the area of the base times the height. Now, we were given the height, all right, it's 4 inches tall. So great. But the area of the base is another matter. All right, we were given the circumference of the base, but not the area. So what you do is you do a side problem, and you come back to this thing. So they gave us the circumference. So like I said before, if they give you something, you should go ahead and write the formula for that and see what you can do. So the circumference, all right, the formula for circumference is 2 pi times the radius. Now they gave us the circumference, all right, so that means the circumference, which is 2 pi times the radius, should equal 10. All right, so in other words, we're just plugging in the 10 for the circumference. So we should be able to solve this for the radius. So let's go ahead and do that. So if we divide both sides by 2 pi, okay, just to make sure, they said the circumference is 10, all right, not 10 pi, just 10. All right, so this is 10 over 2 pi. Okay, so this should give us what the radius is. So that's 10 over 2 pi. Okay, that gives us 1.59. Now, I don't like to round too early, but I don't really have a choice right now. Well, I sort of have a choice. So here's your choice. You can either carry 4 decimal places, okay? So, whoops. You can go ahead and write 1.5915. Okay, and use that for the radius. All right, if you have to round and it's not the end of the problem, you need to carry around 4 decimal places. Okay, so let's not forget our goal. We need to find the volume of this candle, and to do that we needed 1/3 area of the base times the height. So our goal is to find the area of the base next. I think we can do that now. So the area of the base, which is a circle, should be pi times the radius squared. So the area of the base is pi. Okay, now the radius is this 1.5915 squared. Okay, so this should give me the area of the base. So pi times blah 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 squared. Okay, so that would be pi times, and it was 1.5915. Squared. Pi r squared. Okay, so I get this. This is the area of the base. Again, this is not the end of the problem. So I need to carry 4 decimal places for now. So this is 7.9573. Okay, that's the area of the base. So did I leave enough room right here for the area of the base? 7.9573. So now finally I can go back and actually find the volume. So this is really like 3 problems in one. Okay, we're doing volume, but to do that we had to find the radius so that we could find the area of the base. So this is like a 3-stage problem. Very complicated. So 1/3 blah blah blah. So 7.9573. Whoops. So this is 1/3 times 7.9573 times 4. Okay, so now that this is the final answer, I will round to 2 decimal places, the hundredths place. So that's 10.61. And the lengths were in inches, so my volume will be in cubic inches. Alright, so that is it for number 12. Quite a problem that was. Alright, number 13. A spherical scoop of ice cream is 2.5 inches in diameter and sits atop a waffle cone that has the same diameter. The height of the waffle cone is 6 inches. Alright, so we're dealing with a sphere and a cone. Alright, assuming the scoop is solid, what is the volume of the ice cream scoop? Okay, so the ice cream scoop is spherical. It is a sphere. So let's so for part A, all we're doing is we're calculating the volume of a sphere. All right, so here's our sphere. Let's see. It's 2.5 inches in diameter. All right, but what we need is the radius in order to do all the formulas that we have, all right, involve the radius. Okay, so obviously we'll have to take half of that. All right, so 2.5 divided by 2 is 1.25. All right, so we're dealing with a radius of 1.25, inches. Okay, so if I want the volume, now that I have the radius, the volume of this sphere is, we've got the formula 4/3 pi r cubed. All right, so that makes this 4/3 pi times 1.25 cubed. So that's 4/3 pi times 1.25 to the 3rd power. All right, so that's 8.18. Okay, and that's cubic inches. All right, just in case I need any extra decimals later, I'm just going to write them down. So it was 1812, which I probably won't need, but you never know. All right, so anyway, that's what we were supposed to find for part A, was just the volume of the ice cream scoop. All right, so moving on. For part B, what's the volume of the waffle cone? All right, our cone contains the sphere of ice cream, and they are supposed to have the same diameter, and therefore they will have the same radius. So once again, the radius is 1.25 inches. Okay, so we learned that from before. So to find the volume, I will use the formula for the volume of a cone, which is 1/3 area of the base times the height. Alright, so this will be 1/3, and I need to calculate the area of the base and times the height. Let's see, I think they gave us more information about the cone, so I'm going to look back at the top. Okay, it says the height of the cone is 6 inches. Alright, so I know the height of the cone is 6 inches. So all I need is the area of that base. So the base is a circle, so the area of the base is going to be pi r squared. Okay, and the radius is 1.25, so the area of the base will be pi times 1.25 squared. Okay, so I'm just going to do 1.25 squared. Okay, that's 1.5625. And I'm going to carry all the decimals, alright, because it's not the end of the problem, so I don't get to round yet. Alright, so I've got 1.5625 pi. Alright, I might need more space in here. Okay, so it's 1/3 area of the base times the height. Alright, so in the calculator, I see that that is 9.82. Got to round up. Alright, so that's 9.82 cubic inches. Alright, so now for part C, if the ice cream melts and drips directly into the cone, will the cone be able to hold all of the melted ice cream? Explain. Well, the volume of the cone is 9.82, like we just saw, and the volume of the ice cream ball was 8.18. So yes, the cone will be able to contain the entire volume of the ice cream cone because the cone has a larger volume than the ice cream was. So let's just write that down. We could simply say yes, the volume of the cone is larger than the volume of the ice cream scoop, so the cone will be able to hold all of the melted ice cream.